In this video, we're going to discuss the harmonic sequence. Harmonic sequence is a sequence such that the reciprocals of the terms form an arithmetic sequence. Let's write the sequence. 1, 6, 1 over 11, 1 over 16, 1 over 21, 1 over 26. So by the definition, we're going to get the reciprocals. 1 over 6 becomes 6 over 1, or just simply 6. Then we have 11, we have 16, we have 21, we have 26, and so on. Then this should be an arithmetic sequence. So let's try that. From the definition of the arithmetic sequence, that is associated with the common difference. Okay, and to find the common difference, we should subtract a term to a previous term. Let's say, for example, the second term will be subtracted by the first term, and that will be the difference. So, in doing so, we have 11 minus 6, that is 5. Then, 16 minus 11, that is also 5. 21 minus 16, that is 5. And 26 minus 21, that is also 5. So, 5 is our common difference. And since we have common difference, this sequence is an arithmetic sequence. And since the reciprocal of the terms form an arithmetic sequence, this sequence is a harmonic sequence. Let's write this one. We have 3/5, 3/7, 1/3, 3/11, 3/13. So, by the definition, we're going to get the reciprocal of each term. 3/5 becomes 5/3. Then 3/7 become 7/3. 1/3 becomes 3 over 1, or just simply 3. 3/11 become 11/3. And 3/13 become 13/3. So from our reciprocal of the terms, let's find the common difference by subtracting the second term to the first term. So we have 7/3 minus 5/3, we have 2/3. Then 3 subtracted by 7/3, so we can simply write 3 as 9/3. Because if we're going to simplify this 9/3, that is also equivalent to 3. So 9/3 minus 7/3, that is also 2/3. Then 11/3 minus 9/3, that is 2/3. Then 11/3 minus 13/3 minus 11/3, that is also 2/3. So this is the common difference. And this is an example of arithmetic sequence. So from here, we can confirm that this example or this sequence is a harmonic sequence. So let's take a look at the formula of harmonic sequence. Okay. So does it look familiar to you? If yes, because that is just the reciprocal of the formula of the arithmetic sequence. So we have a sub n equals 1 over a sub 1 plus quantity n minus 1 times d. A sub n being the n term, a sub 1 is the first term, n is the term position, and d is the common difference. Now, let's try to solve problems using this formula. Let's have example number 1. Find the 14th term of the harmonic sequence 56 over 113, 56 over 177, 56 over 241, 56 over 305, and so on. So, by the definition of the harmonic sequence, we're going to get first the reciprocal of the terms. So 56 over 113 becomes 113 over 56. So we have next 177 over 56, 241 over 56, 305 over 56, and so on. Then let's identify the given. So the first term is 113 over 56. N is 14 because this is our term position. 14, or the 14th term, is what we are going to find here. Then for the common difference, we're going to subtract the second term to the first term. So we don't need to subtract third to the second, fourth to the third. There's no need for that because this is an example, or this is already a harmonic sequence. So we're going to find the 14th term of that. So let's just have the second term minus the first term. 177 over 56 minus 113 over 56. So the common difference is 64 over 56, or if we're going to turn it in lowest term, that is 8 over 7. Since our given is complete now, we can use our formula. So A sub n equals 1 over A sub 1 plus quantity n minus 1 times d. So let's just substitute the values or the given. So for the A sub n, we have now A sub 14. This pertains to the 14th term, or the value of the 14th term. Then 1 is constant over 113 over 56, that is the first term, plus 14 minus 1. 14 is the term position or the value of our n. And here, we have the common difference. I prefer to use the 64 over 56. Okay, because later on, that will be the easiest way to simplify the denominator because they have the same denominators, 56. So let's simplify by subtracting 14 and 1. So we have 14 minus 1, that's 13. Then 13 times 64, that is 832. So in the denominator of 1, we have 113 over 56 plus 832 over 56. Then let's simplify it. We have 113 plus 832 is 945 over 56. Then get the reciprocal of that, multiply it to the numerator, that will become 56 over 945. Or if we're going to turn this into lowest term, that is 8 over 135. So both numbers are divisible by 7. So this is the value of our 14th term. Next example. The third term of a harmonic sequence is 1 over 13. And the 20th term is 1 over 64. We're going to find the first term of the sequence. So let's identify the given. We have the third term, which is 1 over 13. The 20th term, which is 1 over 64. This is unknown, the first term. And also, we're going to find the common difference. So as you can see, we're going to use the formula. We have two unknowns, the first term and the common difference. So what we can do here is to get the reciprocal first of the third term and the 20th term. So 1 over 13 is 13. And 1 over 64 is 64. Then we're going to use this formula, the formula for the arithmetic sequence. Why? So by substitution, you will see. So we have 13 equals the first term, that is unknown, plus 3 minus 1. Why 3 minus 1? N is equal to 3 because this is the third term. So the term position. And the value of the third position or the third term is 13. That's why we have 13 here. So again, we have 13 equals A sub 1 plus quantity 3 minus 1 times D. D is also unknown. So we have two variables to find. Okay, so let's do the same thing later in our 20th term. So let's simplify it first. We have 3 minus 1, that is 2D. Okay, 3 minus 1 times D, that is 2D. So for the third term, 1 over 13, we have 13 equals A sub 1 plus 2D. So let's do the same manner in the 20th term. We have 64 minus or equals A sub 1 or the first term plus 20 minus 1 times D. So why 64? Because the 20th term is 64. Okay? That is 1 over 64 rather. Then, 20 is the term position. That's why we have 20 minus 1. Then simplify. We have 64 equals a sub 1 plus 20 minus 1 is 19. So we have 19D. So we have two equations. The first one is the one that we got from the third term. So we have 13 equals a sub 1 plus 2D. And the second equation is the one that we got from the 20th term. That is 64 equals a sub 1 plus 19D. So through these two equations, we can do elimination. Okay, by subtracting the two equations. So 64, let's have first this. 64 equals a sub 1 plus 19D. Subtracted by the second equation. We have 13 equals a sub 1 plus 2D. So in the first step, we can eliminate a sub 1. Okay? So 64 minus 13, that's 51. Then we can cancel out the a sub 1 because a sub 1 minus a sub 1 is 0. Then 19 minus 2, that is 17. Then copy the variable. Then divide both sides by 17. So 17 divided by 17 is 1. Then 51 divided by 17, that is 3. So we found now the value of the common difference. We have 3. So we can use this to any of the equations to find the value of the first term. So let's say, for example, we're going to do it in the first equation, or in this equation, we have 13 equals a sub 1 plus 2D. So let's substitute the value of our common difference, which is D. So we have 13 equals a sub 1 plus 2 times 3. So that is 6, right? Then isolate a sub 1. We have 13 minus 6. And the first term is 7. So let's see if we're going to do the same manner in the next, or in the other equation. Let's see if we're going to find the same answer, or first term is equal to 7. So, okay, so we're going to get the reciprocal first. Okay, that is 1 over 7. That is the first term of the sequence. So let's have 64 equals a sub 1 plus 19D if we're going to get the same answer. So let's substitute. 64 equals a sub 1 plus 19 times 3. So 19 times 3 is 57. Then transpose it. We have 64 minus 57. And that is also 7. Then get the reciprocal of that. A sub 1 is equal to 1 over 7. So 1 over 7 is the value of our first term, or the first term of our sequence.